Very good afternoon. Welcome back to the second session of day first of five-day class. Now Shinohara will continue his talk on the topic review and recent R&D research and development activities of radiative wireless power transfer. Part 2, which will be focused on history and recent research and development activities as well as business. Okay, thank you.
Yeah, so let's start. Yes. Okay. So hello again. So thank you for coming back to my talk in the afternoon. So from here, I'd like to introduce history and recent R&D and business of the radiative wireless power transfer mainly. So now there are a lot of various kinds of the wireless power transfer via radio wave or radiative WPT. So I will explain later. Historically, originally, this beam type or narrow beam WPT was carried out in 60s mainly. And recently, we changed our mind to realize this beam type WPT to the ubiquitous type WPT. It is named wide beam WPT or like Wi-Fi or RFID or the other weak power and low efficiency, but multi-users. And this technology can be applied as an energy harvester from the ambient radio waves. So this system is very low frequency WPT and low power and multi-user. It means we can use the power source from the ambient radio wave from the wireless communication radio wave or the other. And additionally, we cannot overcome the Maxwell's equation, as I mentioned in the morning. So for this technology, unfortunately, we cannot increase much power or much efficiency compared to the what you think. So recently, some people consider the application of the WPT in room or in closed area to use the multipath as energies. So based on this category, I'd like to explain the recent R&D and the business of the wireless power transfer. But before going to the 21st century, I'd like to introduce a history of the wireless power transfer. This is a one-page summary of the wireless power transfer, but we have three big turning points. One is, as I mentioned, Nikola Tesla's. So he carried out the first WPT experiment in the end of the 19th century. And in 60s, William Brown started to apply the microwave as an energy. And after 80s, we Japanese started the wireless power transfer R&D by leadership of the Professor Hiroshi Matsumoto. And now, fortunately, there are a lot of WPT products in the world. So first of all, I would like to explain the history of the wireless power transfer in the first of the 20th century, of the end of the 19th century. So he is scientific giant, Nikola Tesla. Of course, maybe you know, he is not a scientific giant of the wireless power transfer only. He is an all scientific giant to wired transfer technology or the other, and he got a Nobel Prize. And in the end of the 19th century, he started the WPT demonstration of the resonance WPT, inductive WPT, and the radiative WPT. And this is named the Tesla Tower to carry, to provide the wireless power to everywhere in the world. And at last of his life, he promoted the world system with help of the resonance WPT. Everywhere on the earth, we can receive the wireless power. And this is his first WPT experiment to use the 150 kilohertz and 300 kilowatts wireless power. But unfortunately, he failed because he can use only the 150 kilohertz, and based on the Friis transmission formula, unfortunately, he could not focus the wireless power into one. And at that time, user required much power to turn on the light, not turn on the IoT device. So disagreement, this matching with the user requirement of the technology, unfortunately, he failed. So this is the reason why Tesla fails in the end of the 19th century. Based on this Friis transmission formula, only with 150 kilohertz, the all power is provided everywhere, like this figure. So unfortunately, he could not satisfy user requirement at that time. But after the failure of the Nikola Tesla in Japan, maybe you know very famous professors, Yagi and Uda, and they invented Yagi-Uda antenna as a super gain antenna with the help of the dipole antenna with a conductor and a reflector, etc. But based on the same Yagi-Uda technology in early 20th century, they carried out the coupling WPT at the 68 megahertz. They named it wave canal. Here, he put a dipole antenna here. And in front and in back, they put just a metal antenna only. And around there, it's Yagi-Uda antenna itself. But they add additional wave canal metals in the enough distance. And this metals named the wave canal was coupled electromagnetically, like the Yagi-Uda antenna. So by help of the electromagnetic coupling, at last, this receiving antenna received enough power. So this is a lost technology in Japan about the wireless power transfer. Of course, in US, Harel Nobel, I don't know him, but in Expo in Chicago, in US, he carried out the WPT demonstration. Here you can see the dipole antenna, and he used the 100 megahertz, and he transmitted at this book 15 kilowatts wireless power above their head. I suppose this is very dangerous experiment and a demonstration. But at the time, he did this demonstration at the Chicago World Fair in 1933-34. But after this Yagi-Uda antenna demonstration and Harel Nobel's demonstration, WPT was not major. Wireless technology is major for the wireless communication mainly. So in 60s, William Brown appeared suddenly. He carried out the microwave-powered drone demonstration in the early 60s and the end of the 60s. He adopted 2.45 gigahertz microwave to fly this drone. And the reason is very simple. William Brown used the 2.45 gigahertz to increase the aperture of the antenna, or to increase the received power based on the Friis transmission formula. So by help of the higher frequency microwave, he could realize the narrow beam WPT, one transmitter, one receiver with a higher efficiency. So when he succeeded the demonstration of the microwave-driven drone, the other famous researcher, not professor, Peter Glaser, proposed the solar power satellite application with the help of the beaming type WPT in 1968 in this paper by only one author. So Peter Glaser was not a professor. He's a researcher in the Earth sector. And I suppose he watched the demonstration of the William Brown. And he found we can transmit the wireless power even at the 36,000 kilometer distance, even from the space. So he designed this solar power satellite at the same time of the William Brown demonstration. So this solar power satellite, SPS solar power satellite, is one of the biggest applications of the beaming type WPT. I'll explain the recent R&D of the solar power satellite in next lecture. And this is the highest beaming efficiency demonstration in laboratory by William Brown. Here you can see he put a magnetron of the 1 kilowatt and 2.45 gigahertz. And he put a receiver at a distance of the 1.7 meters. And at this distance, he develops a very high efficiency rectifier rectangular array. And as a result, conversion efficiency of the beam from transmitting antenna to the receiving antenna was 25%. And conversion efficiency at the circuit at the magnetron was 69%. At the receiver, conversion efficiency was 82%. As a result, totally multiply 69, multiply 95, multiply 82, reach 45 conversion efficiency from electricity to electricity via microwave. This is a world record of the wireless power transfer, narrow beam WPT. And the solar power satellite was designed based on this parameter, 50% conversion efficiency from the electricity to the electricity, even at the 36,000 kilometers. So William Brown expanded this WPT demonstration outside. And he got a very huge budget, I suppose. And in 1997 in Goldstone in Los Angeles, near Los Angeles, he carried out the 1 mile, about 1.6 kilometers distance WPT demonstration with help of the 26-meter diameter parabolic antenna and 3 meter by 7 meters receiver. And he adopted Crystron, high power microwave transmitter, and he transmitted 450 kilowatts as a microwave. And at last, as an electricity, he received the 30 kilowatts. So this is the longest WPT demonstration with the highest efficiency. Of course, beam efficiency can be estimated from the transmitting antenna to the receiving antenna, and the beam efficiency was only 8%. But it is we cannot overcome the maximization and the Fritz transmission formula, so it's a very good number at this 1 mile distance. And this is a very famous picture, and we can read it on the papers, journal papers. But recently, I found the movie of this experiment on YouTube. I was very, very surprised. We can watch the 60s demonstration as a movie on the YouTube. So it's a very long movie, and I have to skip this movie. This is wireless powered drone with help of the microwave power only. And this is a fixed drone to check the microwave power. And in the next step, he used he is William Brown, living William Brown on YouTube. And this is a microwave edit drone at the time. And these are rectifier, rectainers at the time. And this drone, sorry. This drone could fly only with a microwave power. It was very amazing technology and a movie on the YouTube. And after success of this drone demonstration, he developed some kind of the microwave drone, free fly, and he developed a very high efficiency rectifier at 2 gigahertz. And this is the same number of the rubber experiment. And this is the other biggest demonstration of the 1 mile power beaming WPT in 70s. This is a rectifier at 1 mile away from the transmitting antenna. And this is a 26 meters diameter parabolic antenna to carry out to carry 450 kilowatts of the microwave power. And here you can see this is a rectifier at 1 mile away. And here you can see when he moved the direction of the parabolic antenna, at the rectangle. In each rectangle receives the microwave power, and light changes the place. So this is a very fascinating WPT demonstration in 60s by William Brown. But even if William Brown had a very excellent technology, based on the maximization of the phase transmission formula, we need over 20 meters distance of the transmitting antenna to carry the enough power beaming. So as a business, unfortunately, the size of the antenna is not enough. So only exception of the application of the solar power satellite, the WPT was lost in the history of the microwave research history. So in 80s, the research of the WPT moves to Japan. Professor Hiroshi Matsumoto, my boss. And this is newspapers of our laboratory's experiment. In 80s, this is my boss experiment. This Chinese character means power from the space. And from 90s, I joined it, his laboratory as a student like you. And from 90s, I carried out a lot of WPT demonstration and R&D. And we all put the movie from 80s on YouTube. So if you are interested in, please check with the keyword of Shinohara Laboratory, or please check this QR code to visit the YouTube channel. This is a QR code to visit our laboratory channel, and this is a QR code of my international conference talks, 1 hour, 2 hour, or more. So this is a very interesting movies. And I'd like to introduce one movie about a rocket experiment in 80s, when my boss was about 40 years old. He carried out this experiment. He put the transmitter on the rocket, and they adopted the mother-daughter rocket system, and the mother carry transmitter, and the daughter carried out the rectifier. And these two rockets were separated in space. And this is a real movie in space from the receiver side. And this rotating something is Earth. He puts a mirror on the backside of the rectangle, and this is a demonstration movie in space in 80s. And my boss was a scientist of the space plasma physics, so he carried out this computer simulation of the counter effect of the space plasma by the hypermicrowave. When I was a bachelor course student like you, I carried out these computer simulation of the plasma physics. And in 90s, when I was a master course student, I joined this Japanese WPT airplane experiment named the MIRAC, Microwave Lifted Airplane Experiment. And before 5 years before this Myrax experiment, Canadian group carried out the microwave-aided airplane experiment, but they adopted the parabolic antenna, like a JPL experiment by William Brown. And in Japan, in Kyoto University, we adopted phased array beam controlling antenna as a transmitter, and we control the beam direction to chase this airplane. And this is a movie of the real microwave-powered airplane. So now, please believe me, here was the microwave power beaming. And from the top of the car, we transmit the microwave power, and at the airplane, he received the microwave power to turn on the motors and could fly. So this is our Japanese memorial demonstration of the beaming WPT in 90s. And this is the world first demonstration with a phased array antenna, beam controlling antenna. Before this experiment, William Brown, Canadian group, they adopted the parabolic antenna only. So of course they could control the beam direction by mechanical, but we Japanese adopted the phased array antenna, and we control the slightly beam direction after this experiment. And in my PhD thesis, I carried out this at the distance WPT demonstration with help of the Japanese power company. And I mainly developed a rectifier. And I wrote the PhD thesis with data. And this was only 42 meters at distance WPT demonstration, but beam efficiency reached 74%. Compared to the JPL experiment, it's very great number because distance is very short. So this is my PhD thesis WPT demonstration. And in parallel, in Japan, neighbor university, Kobe University, Professor Kaya, he was a student of my boss, Professor Hiroshi Matsumoto, but independently, he carried out some demonstration of the WPT to the flying airship, or a third demonstration of the space experiment of the WPT. And with help of the US TV company, he demonstrated a 150 kilometer point-to-point WPT demonstration between Hawaii Island. Here you can see transmitting antenna was, but based on the Friis transmission formula, unfortunately, power is very, very tiny. So compared to the noise, he succeeded receive some signal from the transmitter at 150 meter distance. But it's unfortunate there is no journal paper to describe this demonstration. I don't know why, but Professor Kaya was one of the pioneers of the WPT demonstration in Japan. And after the William Brown, there is a very few group to carry out the WPT R&D in US, mainly Texas A&M. A&M means agriculture, and I forgot it, but agricultural university. Professor Kai Chan carried out a lot of excellent development of the rectifier, beaming WPT, etc. And it was 90s, so about 35 years ago. At that time, he had already developed a 35 gigahertz rectifier, or highest efficiency C-band rectifier, or developed a dual band rectifier, etc. And he was a student of Kai Chan, James Max Padan. They wrote a lot of jointed paper in the IEEE Explorer. But recently, of course, unfortunately, he was already retired. But he keeps a research as an engineer in Raytheon company in US. So recently, his name arises again to the recent R&D research from the Raytheon company. And after help of the William Brown, there was a very interesting demonstration. Same similar wireless drone project in University of Fairbanks, Alaska. And he developed very similar kind of the William Brand's drone, and he carried out the demonstration of the microwave aided drone again in Alaska. They wrote some PhD thesis and some papers only, and after retire of the professor in the University of Fairbanks, unfortunately, their technology was lost in US. But this R&D in US keeps with small groups, and at last, with collaborative research with Japan, Russia, and the US, they had the demonstration project plan of the ground-to-ground microwave power transmission experiment at Reunion Island, close to Africa. And at that time, their plan was to carry the wireless power to the guest house at the valley, on the bottom of the valley. And this is a very good sightseeing place, and they didn't want to put wired line to keep very beautiful view. So instead of the wire, they proposed the wireless power transmission from the top of the mountain to the guest house at the valley. And at that time, they developed a very large rectifier array, but unfortunately, after success of development of this rectifier array, all budget was stopped. So this is a lost demonstration at the Reunion Island in 90s. So at that time, in the end of the 20th century, there was a non-IEEE WPT journal. Of course, these journals are not on the website. So this is only a paper journal at the end of the 20th century. It is named Space Power. Of course, it is originally from the Space Solar Power, etc. But here you can see there are a lot of fascinating papers. For example, this is the most important paper in this journal to estimate the 100% receiving antenna efficiency as a infinite array antennas. And this is the other interesting paper to carry out the global simulation like limit to growth by Roman Crab with a solar power satellite. And if you are interested in this paper and this journal, I have it. So please ask me. It's a very important journal. And now we have a IEEE WPT conference named Wireless Power Transfer Technology and Expo. But in 20th century, there are some WPT conference named SPS 21st, WPT 25, etc. These are non-IEEE conference, and there is no data on the website. But as a student and as a young researcher, I attended this conference and I have a proceeding of the papers. So we have a long history of the wireless power transfer from the end of the 19th century, and at least microwave power transfer has a long history from 60s. So this is additional information. This is the sign by Peter Grazer. So when he arrived in Paris, where I was a student, and I met him, and I got this sign of the Peter Grazer. It's my treasure. In my research life. And from 21st century, recently, as I mentioned in the morning, MIT, Massachusetts Institute of Technology, proposed the resonance coupling. They add the capacitance on the coil as an inductor to create the resonance phenomena. And with the help of this resonance coupling, they can extend the distance between the transmitter and the receiver, even if there is no radio wave. This is coupling WPT, but they can extend the distance. So a lot of people consider this resonance coupling technology is a revolution of the WPT. But recently, we analyze a lot the difference between the inductive coupling and resonance coupling, and exactly meaning there are no big difference between the resonance coupling and inductive coupling itself. And recently, compared to the resonance coupling, radiative WPT is enough. Or to charge your mobile phone, only inductive coupling is enough. So recently, of course, this is a very excellent technology of the resonance coupling, but recently, now R&D and the business of the WPT is divided clearly into very short distance inductive and far distance the radiative WPT. So here you can see there are a lot of coupling WPT standards based on the magnetic inductive coupling. Chi standard by the Wireless Power Consortium is very famous in the world. And recently, some US company and a Japanese company is promoting the wireless charger for the EV. And now in Japan, we have a near-field communication system to ride on the rails or buses. I suppose in India you use the same IC card near-field communication system in your pocket. And now, so business of the coupling WPT are excited in the world. And after excitation by the MIT's revolution, there are very active discussion in the ITUR. ITU means the International Telecommunication Union, and it's like a United Nations of the radio wave. All novel or new radio wave applications, including WPT, wireless communication, remote sensing, must be discussed in this ITUR before business. So after the tough negotiation with conventional wireless communication group victims, we must discuss about the new technology. And first, we propose question what is a novel technology of the for new business like wireless power transfer, etc. And based on this question, we discuss a lot. Sometimes 2 years, 3 years, 5 years, and after agreement with all members in ITUR, not only with national delegate, but also the company member is involved. And we publish a report, and after publishing a report, we reach recommendation by the ITUR, and at last, we would like to reach the regulation. And in 2015, we reached an agreement to publish the application of the wireless power transfer via radio frequency beams. So this is a formally first published document of the application report of the radiative WPT in ITUR. So we need totally about 30 years to publish this ITUR report. And in this report is open on the website. And please check this website, and you can download it freely through this website. And in this report, we cover all technology about the wide beam WPT to the very weak powered sensors and narrow beam WPT involving, including a solar power satellite or the wireless powered drone, etc. And this is just a report, like your report for this GIAN course study. So we need a recommendation. After agreement of this report, this covered technology is very wide, from milliwatt wide beam to the gigawatt solar power satellite. So for the business, we have to pick up the effective business WPT system and we choose a wide beam weak part WPT, and we again published the new report about the impact study and the human hazard issue of the wireless power transfer via radio frequency beam. And in this report, we focus mainly the wide beam and weak powered multi-user application only. And in this table, it involves documents from Japan, the US, or the other countries. And so this is a very good report to check the impact study and human hazard of the WPT with victims. And based on this report, we spent a few years, and we published recommendation formally from the ITUR. And in the recommendation, they only recommend the frequency range for the wide beam WPT, but it involves the millimeter wave, 61 gigahertz. And in this year, US group would like to put the 24 gigahertz between C-band and the 61 gigahertz, and we keep discussion to add the 24 gigahertz in this recommendation. And after agreement of the recommendation and report in the ITUR, we Japanese has already established the new radio regulation for the wireless power transfer in Japan 3 years ago. And this is a detailed permitted legal WPT parameters in Japan. So we choose 3 frequency band and 3 WPT system, 1 watt at UHF to 920 megahertz band, and 15 watt at 2.4 gigahertz, and 32 watt at 5.7 gigahertz. And but we have some restriction, indoor only, and these 2 high power WPT application, we need a special license. But recently in Japan, fortunately, there are a lot of WPT base station as a legal system. So, so this is the Japanese way. But in the world, there are a lot of different WPT application in the regulation. In Japan, we consider the WPT is one of the radio application, so we need a license. But in US and in China, 2.4 and 5.7 gigahertz is ISM frequency band legally. ISM means industrial, scientific, medical band. And this frequency band, we don't mind any harmful interference to the existing application. So US consider WPT is one of the ISM application, non-wireless communication application. So FCC, US Federal Communication Commission, permit some US company, startup company, to use these frequency band as a WPT product. China is the same. And Europe, so they consider the WPT is one of the short-range device, one of the like near-field communication. I explain now. We have an inductive coupling WPT and a radiative WPT. And originally, discussion in the ITUR is started from the inductive WPT. So European group consider almost all WPT is a short-range device. So now they consider WPT is a short-range device. So even if we have an ITUR recommendation, we work together, but in the different world now, unfortunately. So I want to support from India. So of course, Indian delegate of the ITUR always attended the ITUR discussion, but there is no effective document from India. So if you are interested in the WPT technology and the business, please join this discussion, not only in ITUR, but also IEEE or the other. So recently, so WPT business is started from the wide beam WPT because power requirement by users decreases, and even if we have a microwave frequency technology, size of the antenna is required wider than what we think. So to reduce the size of antenna and to consider the cost of the transmitter, now we change our mind to provide a wireless power transfer, wireless power to multi-users with very low power as a business. So this is the current status of the 21st century WPT technology. And for example, 2004, in my laboratory, when I was young, we carried out the wide beam WPT demonstration. But at that time, this is not a good system as a business. So I wrote some papers only. But this is the first demonstration of the wide beam WPT for the business application in the world. And in parallel, in Kyoto University, we propose a simultaneous wireless information and power technology. At that time, we adopted the Zigbee low power wireless communication system. At the same frequency band, we transmitted microwave wireless power and Zigbee wireless information simultaneously. And to suppress the interference with the help of the pulse technology, we succeeded in this sweep technology about 10 years ago. And recently, WPT market is expected to the over $1 billion market in the world. And in Japan, as I mentioned, 3 years ago, we established legal WPT regulation. And during these 3 years, for example, in this May, there are 470 WPT legal base stations in 26 buildings. But now we are in the August, end of the August. And after this data, 3 months pass, this data increases over 65 WPT permitted legal WPT base station now in Japan. So I expect this number of the WPT base station is increasing like a Wi-Fi base station. For example, this is one example of the Japanese startup company. They put a battery-free thermal sensor or the moisture sensor in the building, and they control the air conditioner and the temperature, moisture in the building, in room. And with help of the wireless power, they manage the energy of the building itself, and as a result, they can reduce the total electricity in the building with the help of the wireless power transfer. So this company name is Italink, and this is a very good company in Japan. And the other big company, Panasonic, maybe you know, Japanese big electric company, is developing the wireless powered vital sensor named Enisphere, for example. And the other startup company, MyRelated, is developing beaming type WPT to drive the wireless digital picking system or to drive the rotating motor. So these startup company or the big company, Japanese company, are promoting the wireless power transfer legally recently. And of course, in the world, in US, in Korea, in China, there are a lot of interesting WPT products based on their domestic radio regulation. And this is a very impressive WPT product in US. This here you can see this is Amazon.com, and here you can see this is a very easy to understand. This is a gaming machine Switch of Nintendo, and of course this Nintendo Switch must have batteries now. So their products in US startup company PowerCast produce the wireless charger for the Nintendo gaming machine. So this is a legal system in US. So of course I can visit Amazon.com and I can buy it, but I live in Japan and you live in India. So this system is based on the US domestic regulation. So unfortunately, I cannot buy through the Amazon.com now. But this is a very interesting WPT product in US. But over 600 WPT base station, compared to the Wi-Fi base station, it's a 2-order, 3-order smaller number in the world. So I consider how to expand the WPT business in the world. So I think a practical consideration in industry. Of course, if we don't have a wireless power technology, now you have a battery and you have a wired power, and sometimes you have a solar cell. So the existence of the alternative technology is very important. So we have to consider pros and cons with the wireless power or the alternative technology. So unconscious power is very good benefit of the WPT, but demerit is low power and low efficiency. So how do we solve this low power and low efficiency and additionally public acceptance with the human safety and interference? I consider at first for the wide beam WPT, receiver technology is most important to increase the receiving efficiency. So in the world, year by year, conversion efficiency of the receiver with a diode increasing and increasing year by year. And in Kyoto University, for example, we have already reached over 91% at the UHF frequency band as a receiver. So in the world, there are a lot of good paper to develop the rectifier with a very high efficiency. So at the first stage, based on the current legal system, we need very excellent receiver in consideration of the conversion efficiency. But we need the more technology in future. So I propose beam controlling and beam focusing technology again to increase the beam efficiency and to suppress the interference to the existing victim and the human safety. So for this technology, we have to apply the phased array beamforming technology. In Kyoto University, we try to develop a lot of interesting phased array system in consideration of the cost of the efficiency of the other. And we carried out a lot of novel beamforming demonstration, simulation, etc. So in Kyoto University, we have a good technology to push the WPT business in advance, I think so. This is one example. This is a novel beamforming technology named retrodirective in-room. In-room means a multipath retrodirective. We can avoid the human body itself with the help of the reflection by walls, and we control the beam form like this figure. It's very safe system because we avoid the microwave beam into the human body, and we use the multipath with the help of the reflected wall. So this is originally from the US company's patent, but we simulated and we show the good proposal of this multipath retrodirected system. I will explain the detail tomorrow. And if we have a good beamforming technology, of course, we can fly drone again. So this is a micro drone. Of course, compared to the William Brand technology, it's very small drone, but we add a very novel beamforming technology named flat top beam, and with help of this beamforming, this drone without any battery could fly forever. But this is a research result by my PhD student 3 years ago, and he stopped this demonstration only in the 7 minutes. He said, why? I asked him. His answer is, microwave is no problem. He kept the stable microwave power to the flying drone, but motor will be broken. So he said he stopped this demonstration only in the 7 minutes only. But theoretically, technically, this drone could fly without any time restriction and forever. And recently, we increased the frequency to the millimeter wave to 208 gigahertz. And this is one example of the developed low-cost phased array antenna at the millimeter frequency. I'd like to explain the detail tomorrow. And recently, to increase the frequency in US group, not in Kyoto University, in US group, Raytheon developed a very good diode for the 24 gigahertz rectifier. Efficiency is over 60%, and it's very excellent technology at the millimeter wave rectifier. And recently, around the millimeter wave close to 100 gigahertz, there are a lot of development results in the world. Please check the website of the IEEE Explorer. So these are recent R&D of the wireless power transfer business and the technology. So we can classify these technology again. To increase the beam efficiency, we have to put the receiver at the Fresnel region. And for the wide beam WPT, we put the receiver at the Fraunhofer region. But difference between the wide beam and narrow beam is in the distance between transmitter and receiver only. We use the same technology. So based on this antenna propagation technology, we can design a very good WPT system, not only for R&D, but also for business. So that's all my talk. So thank you so much.
Thank you very much.
Yes, thank you so much.
For this second part of review process, especially focused on your own laboratory works. Let us have a tea break of 10 minutes.
Yeah. Yes.
What was the objective for the drone work? Why the person to the drone?
Sorry, I cannot hear you.
You showed a video of a drone flying. You have shown one video where drone was flying through microwave power. Give us asking regarding that one.
Yeah, so our demonstration of the drone distance was only 80 centimeters.
Okay.
But William Brown's experiment at 60. So from the video or the paper, distance was a few meters above from the transmitter.
So what was like the efficiency? Like
In my experiment, in my Kyoto University experiment, efficiency from the transmitting antenna to the receiver about 1%, so 7 or 8% only.
okay.
And of course, we need a larger antenna to increase the beam efficiency. I will explain tomorrow. But this is a limitation of the Friis transmission formula, and theoretically, it's a limit of the from our adopted antenna size in this experiment. So if we need to increase the efficiency based on the Friis transmission formula, only the way as an engineer is to increase the frequency. So at last, I introduced the millimeter wave R&D for the advanced WPT to increase the efficiency.
Okay. Thank you, sir.
So 10 minutes break.